Oh, you're here. Welcome to vvvvTv, the latest and hottest propaganda channel for all things vvvv. My name is Jorik. I'm one of the guys behind vvvv, and I want to welcome you to this kind of pilot episode of vvvvTv, where we always want to show you the latest hot bits and sexy tricks when using vvvv and VL. So you might not be aware of this, but vvvv today is being created by a bunch of angry old men who are totally out of touch with today's cool kids. That's why corporate management has decided to entrust me, kind of the young gun in the team, to connect with Generation X by setting up this trendy YouTube vvvvTv channel, where we want to try to get in touch with you. But make no mistake, you might be one of the old angry men yourself. Here's a little tip: you can identify yourself as such by if you notice that some of the things that you see on the channel you don't find cool, then that might be the case. And in this case, you might want to drag your kids in to watch this show with you, and they can maybe explain some of the slang that's happening here to you. There's no shame in that. So welcome once again in our cozy Hauptstadt studio, where we want to discuss the latest hot topics with your influencers. We will have all the things you like so much. We will have beauty tips. We will have blockchains. We will track you all around and sell your data just as you like it. So, but I think it's now enough with a serious talk. Let's cut right to the chase. Today's topic is where was that? Here. Computer vision. Everybody knows what we mean with computer vision. It's all those things tracking, filtering, detecting motion in a video stream. And there's been this Trautner and Contours node early on in vvvv. Then it was in 2012 when trusted member and hacker of the community, Elliot Woods, released his amazing image pack that is still the #1 go-to pack, of course, when doing anything computer vision in vvvv today. But also today we want to show you something new we've been working on for the last 2-3 months. It's a new computer vision pack for VL. And I say we because it is at this stage my great pleasure to bring on our first guest and influencer to the show. We welcome Mr. Don Alonso, who has been doing most of the heavy lifting on the pack, and so I thought it's most appropriate to learn from him. So please give a warm welcome to Mr. Don Alonso. Oh well, sorry, I gotta drag him in. So you're in the frame, everyone. Just like that.
Yeah. Hi, Jorik.
Hi, Don. Welcome.
Good to see you.
Good to
Thanks
see
for having
you.
me.
Pleasure. I already said we wanna talk about this new CV pack you've been working on.
Yes.
And I guess we should just jump right into, and let me switch to, which is it, #3. We're switching right to your desktop, and here we've prepared a vvvv patch with a cloned VL template. We don't want to explain how that goes. Just look it up on the internet if you don't know how that works yet. But so we think people have cloned their template. They want to work with computer vision in VL. What do they have to do?
All right, let's dig right in. So the first thing, assuming you have this scenario with your clone template, you want to install our package.
Yeah.
And to do that, you just click over here on the document menu, come to Manage NuGets, go to command line, and in this classic good old command line, you just type in NuGet install VL.OpenCV, and you have to add the pre-release parameter because this is not yet a final version.
Okay.
And once you have that, you just hit enter, and it downloads and installs the dependencies. You might get a little bit of a different output back home if you have not installed it before, but it's a matter of seconds and you have everything you need.
And then we can close that window again?
You can close that.
A little bit.
All right. And the next thing you need to do is reference this newly installed NuGet in your VL document. To do that, we just open the Node browser and type in, oh, seems like we already had it over here. So let us do a bit of cleanup real fast.
So rewind, can we just cut here? And we start again from scratch. We've prepared this marvelously before, and obviously. So how we have now downloaded the thing.
We just downloaded the thing.
Yeah.
We have done nothing else, and now we want to reference it in our document. So we type in OpenCV, and you see right here we have this package icon, right? And it says VL.OpenCV. So you just click there, and immediately, as you see, you have already the OpenCV category available.
Which comes with the pack.
Which comes with the pack, which is the pack in itself in a way. And so if we go in here in the OpenCV category, you can see already our node set as it looks. We have some different categories to organize things for you. All things calibration go here, drawing tools, filters, syncs, which would be your destination nodes, sources, which are your input nodes, tracker stuff, and of course general utility nodes.
Okay.
And that's basically it.
So what the most simple thing I want to do is I want to display an image.
All right, let's get right into it. So first thing, if you want to display something, you need a source, of course. In this case, we're going with the video in. The video in is basically a direct show camera, any one you have back home. And now we need to display it, and for that, as we are very used to already, we have a renderer node. So we just add that guy in, connect this here, and bam.
Okay, that was simple.
That was simple.
So now I say, but I have different cameras connected because this is now just the webcam, right, of the default outputs.
Yes, of course.
With the laptop here.
Here on my first pin, I have my video input device enumeration. And if you right click there, you will see a list of all the currently connected devices.
Okay, so
and you can switch in between them by just selecting another one. This is now our PS3 camera we have on the side. You can go back to the other one. And also, yes, so we have another camera here just to show you that this enumeration of devices is dynamically updating. So in this case, if we connect this other device
to a free USB plug somehow.
Yeah.
Careful.
And now it takes a minute for Windows to come back on.
And we get a nice crash.
We get a beautiful crash, as is expected in any demo. But we just click continue, and as you can see, I can now select this camera, and it's alive right there for you.
Now, the idea was to demo that we can even unplug this.
Correct. Of course, you get a red node over here to notify you that the device is no longer available. But if you were to plug it back in, yes, in a matter of seconds, it should be again live.
Or crashing.
Running, or crashing. But we got lucky, I guess. All right. Cool. So that's the most simple setup you can think of. We have a few other things over here: width, height, frames per second. Since we have this nice PS3 camera, we
can go up to 60.
Yeah, let's crank it up over there.
Cool.
Okay, so that kind of covers the typical in-out.
Next, I want to put a filter there.
Filters, of course. We all love our filters. Let's just double-click right here.
As we're used to in VL.
Yeah, in VL, you can just put your nose straight into the link. And let's go with something classic. I say medium blur, or no, let's go with an invert first.
Yeah, classic.
So
Easy.
as you see right there, we have our invert. It's a chainable filter. It's something you can enable and disable as you wish. And when I say chainable, what I mean is that you can concatenate a lot of them. So let's add another one down here. Yeah. So
now the medium blur.
let's try this medium blur guy.
Crazy shit.
Bam. You have it
Just
right
works.
there. I enable my invert. I disable my blur. I can go like this.
Yeah.
And no
let's add another one. Like, can we rotate the image?
Of course we can. We have a filter for that, which is surprisingly called transform.
Amazing.
And it's something you are probably used to back
Just take
from
some
the
matrix. Yeah.
V4 days. Yeah. And so let us add a transform SRT 2D, and we will just connect it over there. And let's say we want to rotate it, or maybe scale it, translate it.
Cool.
You know, the works.
Okay, that's really the most basic things you
Yeah.
can do, like filter images, transform them. Somehow.
Yeah. We have plenty of filters out there for you. Filter here. And you know.
But
you
how
can
would I know
scan
what any of those filters is doing?
Right. So we took our time and made sure that every one of the nodes we're shipping with VL.OpenCV has their own summary and remarks to try to help you understand what it's trying to do.
Yeah.
If there's anything particular or specific about it, we will let you know there. Even the pins themselves have annotations when it becomes unclear maybe how they should behave.
Yeah. So here in this example, K size, that's the name of the pin, doesn't mean anything to me, but then I get a somewhat more useful explanation that says aperture linear size, it must be odd and greater than 1, for example 1.357. So it gives you at least some hints, more hints than the names. But
Yes.
obviously it's difficult to document all the gory details. But we wanted to
if
show...
you're in need to find more about any of the OpenCV stuff, you can always go to the opencv.org website, click on online documentation, and here now
they have all the documentation of the different versions, but which version?
Yeah, if you're not sure which version you're running from our end, you can always come back here to the document menu, and in your VL Nuggets, VL.OpenCV, you have a little summary here which will tell you what version we're running on. This is now 3.4.1, which is
conveniently the latest.
So if you just click there, you have a nice go-to place with tutorials, introductions.
So that's the official OpenCV.
Yes. You can also search here if you need to find something specific.
Not the most easiest to read really, but you'll have to get used to that if you need some of, like, understand how to parameterize different nodes or something.
Yeah, exactly. All right.
I think we can check that off and should go to the next topic.
Yeah. All right. So let me clear this up.
Yeah.
Bam.
We start right here, and what we wanted to show you is now this scenario where in vvvv you would have used the Trautner node, which does motion detection in areas of an image. So you want to say, okay, if someone waves down here, you want to be notified, or up here, but if someone waves here, never mind. So because we don't have a Trautner node here in OpenCV, but we can build one ourselves basically. That's the point.
So again, the idea is we want to detect changes in specific areas of our image. And the first place I would start is what we call a frame difference. And a frame difference is one of the filters that ship with OpenCV. And as you can see right now on the right, or on your left rather, it's black as long as we don't move, but whenever something changes, it will show you only that.
So now we don't detect the motion really, but we see the motion at least. We have kind of extracted the motion by using this frame difference.
Exactly.
And now the next thing is that we want to basically know the number of pixels that have changed.
Of course, we want to get some data we can use, not just an image. And in this case, again, we have a node here for you that's called count non-zero, and it basically takes in, what's going on in here?
Just shows you a red link because
the data types are not compatible, of course. All right, but it's also complaining about something here. So let's look at the tooltip. One of the nice features in VL now is that you get error messages straight in the tooltip.
So we try to give you some understandable information. It's not always possible to get super understandable. So for example, in this case, let's try to read this. So the tooltip first says what this node is doing. It counts the number of pixels, blah, blah, blah. And then it says something rather cryptic. It says cn equal 1. And this is basically, as you will learn, where the error message starts in this case. And so tell us, how can we interpret this?
Yeah, well, OpenCV error messages, which is the one we're seeing here, are not particularly clear to the beginner. But once you work with it for a while, you get used to it. In this case, as you know, images have channels, which is what we're used to in
like
RGB, RGBA, HSV, and so on. So what this is trying to tell us is this CN stands for channel, and the equals 1 is trying to tell us this particular node can only handle one channel images.
So it requires an input image that has exactly one channel.
Exactly. And
so how do we do that? Because the default obviously is RGB, it's 3 channels. So how do we go from
important that you mention it. In OpenCV, oddly enough, the standard is BGR, which is something you have to keep an eye out because you might get weirdly colored images. It's just a matter of channel order. But in this case, what we want is a single channel image, which is sometimes also called a grayscale image. And we have a node just for that called grayscale, which will take an input image and output a single channel image. And you see the minute we put the grayscale node in there, our count node 0 has stopped complaining. So let's have a look at the output of it.
We have now lost the image because the connection is lost here.
Let us show our grayscale image over there. And if we stop moving, you would expect it to tell you that no pixels are changing.
So that's the count non-zero means it's counting the number of pixels that are not black.
Correct. Yes.
But still, even though we're not moving, the number is quite high.
Yes, which is not what we expected. And the reason behind this is that most modern day webcams and video sources in general are quite noisy. Even if it looks black to you, there's a lot of dark gray pixels changing all over the place. So we need some sort of filtering, something that will increase or decrease the sensitivity of our filter here. And that is what in the business it's called a threshold.
So let's type threshold.
Yeah.
And what a coincidence.
Right there you have it.
Amazing.
And immediately you see that the count is already 0. And when you move,
as I move, I get a count.
Yeah.
And why is that? Already, like the setting, the default setting of the threshold.
Yeah, the default setting of the threshold is already cutting off. So if we want to look at what's happening here,
you see it's a much more sharp output.
Yes, exactly. So all those little pixels that were close to black but not quite black now are, after the threshold, completely black, which is what we wanted. If the results you get back home are different, you can always play around with the threshold value and hone it in for your specific.
Okay, cool. So that's kind of the first part. Now we get changes in the whole image, and the Trautner, the speciality of the Trautner was kind of that you would be able to specify an area of the image that you would only be interested in when changes happen.
That's true. And to me, this sounds like a mask, you know.
Yeah.
And we
Basically,
prepared a mask for this example, of course. And that means that we have an image file somewhere in our hard drive, which is a white and black image, where black is what we don't want to come through the mask and white is what we want through the mask. So now we need to load an image file. And for that, conveniently enough, you have the image file node, which takes in, of course, a path to our mask, which is over here, and a load, and you have some other options which we're not going to go into right now. Now we have this image file, and if you want to look at it, just load it, and that's it, a very simple ellipse mask.
Beautiful.
Good enough. And now we want to combine them. We want this to mask our original content. For that, we have a node called AND, which takes in two images. So let me connect this through. Takes in two images, the source image and the mask in this case. And as you can see already over here, only what's behind the white area of our mask is coming through. So we already have our area of interest right there. And what we need now is just to feed this into our frame difference. Yeah. So now, well, let's visualize it this way so that it's easier for us.
No, or even like this,
yeah.
So now the idea is, if I'm moving down here where you don't see it, then there is, maybe put the threshold a bit up. Yeah, so now nothing is happening. And only in here, really something
starts to happen. Maybe the threshold is
not too high.
Yeah. Now you can see when we're moving here, the amount of non-zero pixels goes up.
And down here, nothing.
Nothing happens.
So yeah, that's kind of replicating the Strautner functionality. Almost, not completely, but yeah, you get the idea. You can, from there, maybe as an exercise to the user.
Yeah,
I guess. That was probably all we wanted to say about motion detection.
In this very simple initial demo, yeah.
And I think since the time is already, I don't know how long we are streaming yet, 10 minutes, 15 minutes?
Something around that.
So let's do one more example, which is more complicated anyway. Let's see how long it takes us. Let's get rid of all this.
There's one more thing we want to show right now, which is, because for our next demo, we will need our image to go through to vvvv.
So the question is, how do we get an image from this OpenCV VL world out into the
v4 world? Exactly. And for that we have two simple nodes, one in VL called toImage. And when you get more than one option, just go with the most simple one initially, and that should be enough in most cases. So in this case, let's say we want this masked video image to go out into the v4 world. We connect it to the toImage node and we create an output. Immediately in v4 you can see we have an output, and now what I need over here is a node called upload image, which as you can see is available for both DirectX 9 and 11. And what that will do is it will take this image from the OpenCV CPU world, upload it into the GPU, and now with this you are completely able to work on the GPU end of things as you're accustomed to. So what we have here now is just the texture, and of course you can render that in your favorite renderer. And
the renderer is down there.
It's down here, and there we go.
So basically, toImage to get the image from this OpenCV world into a more generic image world, and then upload image to get the rather generic image type converted to a texture.
To a texture.
That's it.
That's it.
So also so simple so far.
Yeah, I'm glad you feel that way.
So now we go to the last example.
Yes.
Which is my favorite, and I hope it works.
Let's see how it goes.
For this we need...
Let me connect our
These guys.
render again, which I lost on the way there. And now we're going into the tracker category.
Yeah. So there are a lot of trackers actually there, and we
yeah.
don't want to go into all these.
Yeah, you can have a look on your own and read the documentation. But in this case, what we want to do is
the most exciting one.
Yeah, our favorite one, Aruco marker detection. And for that, you need to create your own Aruco marker. For that, we have a special node called
Draw marker?
Draw marker. No, marker writer.
Marker writer?
Yeah, which will allow you to specify a few settings and then print out your own.
Just save it as a JPEG and print it.
And print it,
what we did
and
here.
that you can play with.
But we're not going to show that. You will figure that out. But
Exactly. So
let's detect this marker.
yes. So we start with the marker detector node, which again takes in an image. We need a dictionary. There's several different options for dictionaries. In this case, we are using a 5x5 dictionary. All right. And to visualize what we're getting from the marker, we need a draw markers node, which will take in the markers themselves. But since this takes in a sequence of vectors and this is outputting a spread of vector, we're gonna do a little trick here called flatten. We take in these guys.
Gets rid of one of the dimensions and just
Exactly.
puts them in a list.
And now we just connect the draw markers there and we connect this here and
You should already see them very small markers.
let me make a nicer, So as you can see, it's already detecting our marker, its corners.
Quite stable.
It's very fast, very reliable, yes.
With this 60 frames camera also we have.
Of course that helps, yes. So this is the first stage. We are detecting our marker already. That's nice. But we want to get more out of it. We want to go into the augmented reality kind of end of things. And for that, we need a new node, which is called estimate pose, which will basically take this information we get from the marker and give us a transformation matrix, which tells us the 3D position of this.
Okay.
All right. Now this is now complaining because the marker length by default is not higher than 0. This is something we will fix for the next release. And what this node takes is basically the corners that my marker detector is giving me. And we need something called a camera matrix and distortion coefficients.
What's that?
Well, that's kind of the physical information about your camera lens, focal length, the curvature and so on, which we need to correct.
But how do I know that?
Well, that's something that comes out of the calibration process for your camera, which we send out notes for already. But in the case of this example, since we don't want to take the time to do that because it takes a bit of time, we have already written our calibration information for this camera into a file, which we can also do with the VL.OpenCV kit. And we're just going to read from that file at this point.
So if you have exactly the same camera, you can use exactly the same file. But if probably you have another camera, you would go through this calibration process, which we also have to explain at some point, and then save your data for your camera. That's what we did here.
Correct. And now this reader will give me exactly what I need, which is a camera matrix and a set of distortion coefficients. My estimate pose node is now stable. Yeah, and you can see here we already have some transformation data, which we will output to V4. And
we removed the 2 image. You have to get back the 2 image.
Yes, that's true. Let's add it again. So we have the video in, the 2 image. And we need one more thing, which is, because this transformation matrix will tell us the position, but we also need our scene, our 3D scene in V4 to have the same distortion and perspective.
Don't mention it yet.
All right.
All right, it's a secret still.
All right, come, cool. Yeah. So we have this. Now, let's get out here. We have prepared, oh no, we're gonna patch that. All right, so we have our transformation.
Image art and transformation art. So basically now we want to put something there, put a cube there where this transformation will put it.
All right, so let's start with, I don't know, what's your favorite shader for this?
Phong, directional.
Phong is fine. We need...
No, I think you just chose...
the wrong one?
Yeah, this one, direction. Yeah.
All right.
I'm not sure, maybe.
All right. We need a box, which is our geometry right here. Bam.
Mm-hmm.
All right. What else do you want?
Just show us that box now.
A light, maybe?
No.
No, it's not necessary. All right. So here we want a group.
Yeah.
We connect this over here, and we connect our box right there. And this is our renderer here. So you can see now it's a flat box. It doesn't have any transformations. If I was to connect this transformation straight in there, and you show a marker,
something happens.
Yeah.
We should turn on the
depth buffer for this guy.
Okay.
Maybe a bit of anti-alias just to make it nicer.
And
you can see something's going on, but it's not quite right.
So,
so we need to do, and the reason for this is that the coordinate system used by OpenCV is not the same as the one that V4 uses. So we need to take a little bit of extra steps in here and make sure we get those coordinate systems to work with each other.
And we have to add that this is a bit of an awkward thing to do, and obviously in the end we want to hide this from you. Yes. But it's still kind of in a research phase. We want to figure out where to best hide it. Yeah. And so for now we just show you what you have to do.
Yeah, so let's begin with the transformation magic. Scale transform vector. This is not gonna make much sense for you back home. We just have tried it around for a while and have figured out this is what we need. We need to multiply this and apply another scale like so. And now if we take in this transformation and connect it there, you can already see it's reacting according to Jorek's movements on the paper.
Yeah, it's sitting there, but it's still too large or something.
Something's still off, right?
Yeah.
Well, like I was trying to say before, when I got a little bit ahead of myself, we need this renderer to understand the same perspective, to have the same optics, so to speak, as our
because
original
at the
camera.
moment it just does not have any perspective. We have no camera or anything connected there. So it's, as you see also, the cube is kind of in an orthographic projection.
Exactly.
So we need to get the perspective.
The perspective.
Where do we get that from?
Well, again, we have a node back in VL called to perspective.
To projection.
To projection transform. Sorry, we always mix that up. And this guy will take the camera matrix you have from your calibration process and also the image width and height, which in this case are the cameras. And you also have this near and far functionality here, which I'm going to just tap down a little bit. And now we output this. We come back to V4. And with this new output we have, we just connect that to the...
Something happened.
Whoa, whoa, whoa.
But, you know, I think one more thing is that we have to set the size of the cube still, because the default cube is 1 by 1 units. And remember, we specified the size of the marker length as in the node.
Yeah, we said it was...
No, in the estimate pose, I think.
We said it was 0.05.
So let's say that's 5 centimeters. And the box is now 1 meter.
wide. Yeah.
So let's scale that down with a uniform scale.
So let's add a uniform scale node here. Connect this there, this there, and my guess is it's gonna be 0.05 again.
Yeah. And boom, okay. It's kind of sitting there, but one more issue I see. What is that? I remember.
Do you remember?
Yes.
Well, let us know.
It's this new feature we have in the renderer.
Ah, that's right. So
Which
not
doesn't
long
make
ago,
sense here, sadly.
yeah, we added auto aspect ratio
Yep.
to our renders, and this is what's causing this slight offset. And as soon as I take that off, you will see that the cube sits right where we want it, rotates with the paper, and
As
you
if
have
it's
it.
just there.
As if it's right there.
Yeah.
Now
Beautiful.
it looks great. I wonder if it spreads. Do you think this spreads?
Let's see.
Wow. Well,
We have prepared somewhere. Here.
oh, there
Found
you go.
it.
Yeah. So this is another set of Aruco markers.
You
It
see
belongs
it's,
to a different
different.
dictionary. Yeah.
Because it has only 4 bits
Yeah.
in each direction.
So we just have to change the dictionary,
Oh.
and immediately, as you can see,
Here we are.
we have the tracking for each individual marker, its translation, rotation, scaling, and so on.
And it's
Right there.
It's really kind of fast. And
Yeah.
if you get, I guess, if you have stable lighting and everything, then it's
Yeah.
pretty-
Like
Quite
with
a
many
robust
other nodes, we haven't exposed all the features you can tweak, and of course, it's all in there. You can just go into the patches and find the features that you want.
So you're
tweak
saying
them.
that obviously there are more parameters to tweak
Yes.
for this tracking, and those are not yet available as inputs.
Yeah, we haven't exposed them to the end user, but if you need them, you can always just go in and tweak around and.
Where would we go in?
Well, in the case of this one example, we would go into the marker detector, which is our entity, so to speak. And you see here we have this create node, and it says OpenCV sharp Aruco detector parameters. And if you were to type in detector parameters here and click in there, you can see a long list of different things you could play with.
And also the documentation about them is again on the
OpenCV.
CV website.
Yeah.
I mean, we will have to look into this a bit of maybe we should expose some of the parameters that make sense by default, but obviously, since it's all available as a patch, you can always just go in there and adapt this node to your current needs.
Exactly.
That's the point.
And most of the library has been patched in VL, so you can just dig into the nodes themselves and look at what we were doing, how we got it to work, and do it on your own. And of course, you can always come here to the GitHub VL.OpenCV website, download the source code as well.
We haven't mentioned that yet.
Yeah. And work with that. Here you will get information about how to install it, how to build it, and so on. And of course, if that is not enough, we are always available on the Riot chat where you can reach us. Yes, we have a link for that, don't we?
But wait, I wanted to get us back out of the image. Like here and now, I can. I can't remember where it was.
No. There you have it.
Look at this. Look at this. This is where you'll find us best. To talk about, like, if you want to contribute to the pack, which we very much recommend and encourage for people to dive into OpenCV and help us develop this further. There's a lot of hidden features still in the OpenCV library that can be exposed simply by patching.
Correct.
So we want to encourage everyone to help us build out this library.
Yeah.
We wanted to give a quick wrap up of all the things that are still already available from our pack that we haven't mentioned at all.
So
we have
we have background subtraction, we have face and object detection, We have trackers of different natures. We have, what else is in there?
Delaunay and Voronoi.
Delaunay, Voronoi,
Triangulation
optical
things.
flow.
The pedestrian tracker.
Yes.
And yeah, so like utilities for image cropping, resizing, inserting parts of images in other images and stuff. So there's a lot of things there that you should just try for yourself. We wanted to show the demos.
Yes, very important, because we didn't cover that much today. But if you install the pack as we showed you today, and let's say this is your vvvv installation, if you go into lib, packs, and scroll down, eventually you will find your OpenCV folder, and in there, if you click in there, you have this. If you go into vvv girl power and open this demo right here, you will end up with this document, and if you read the instructions, it's quite clear. Let me just close what we have in the working over here. And once you're there, you can quickly and easily come back here to your pack, go to demos, and replace this node with the different demos we have here. So if you want to see contours, you just drag it, and there you can see already some things going on.
Let's not dive into this any further, even though it's beautiful.
Yeah.
Look at this.
So there you can go to and find other features, other examples, and learn a little bit more about what's going on.
Cool. Two more things to touch. CUDA, GPU support. What's your status on that?
Yes, CUDA is currently not supported in the package which we're shipping. There are many reasons behind it. The main one being that OpenCV itself doesnn't ship CUDA-enabled DLLs or binaries. And why they don't is that compiling CUDA is a bit of a hassle, especially because you have to deal with CUDA-specific versions and hardware-specific configurations. So
it sounds like even if we at some point figure this out, it will still be a hassle, kind of.
Yeah, basically
you will support different versions and stuff.
Yeah, exactly. So, of course, we're thinking about it. Of course, it's on the to-do list, but we're not there yet.
Yeah,
quite.
And this is where we would also be very interested in seeing someone helping us out. Maybe if someone is into compiling OpenCV with CUDA, please join us on our channel
again
to discuss matters.
Yeah.
That was the first thing we wanted to talk about, and the second thing, now we close this example. Can we quickly open it again? We wanted to show you async. So let's see if we can get that.
All right. As you will find out quickly enough, many of these nodes are computationally heavy, you know. And
so, for example, this video in, you see. Oh, you don't see it. Sorry. Number 3. Yeah. In the tooltip, you see very heavy node, the video in.
Exactly. And the same is true probably for the marker detector. We haven't read this. That's why.
Oh no, it's crashing.
Well. There we have it. Well, one crash per video is a healthy amount of crashes, I would say.
Let's try again.
Let's go at it again. And don't put the markers in until I read my calibration information.
Okay. Reading the calibration information. Can I?
Yeah, you should be good to go.
But we have nothing connected, the thing.
I think it's more about this.
Yeah, okay. You see the markers. Let's not use the cubes. We lost them. But we show you that this is a heavy operation as well as the video in.
Exactly. And if you're working with a heavy patch, this is going to get in your way. It's going to make your patch slow. And this is clearly not what you wish for. So we're still designing better solutions for this. But the recommendation right now is to use a region called an async loop. And this will allow you to run the heavy tasks in a separate thread so that they're not hogging up your main loop and your application.
Let's make some space here maybe first.
Yeah.
Let
me
we want to put this. So the heavy parts are basically marker detector and video in.
Correct. So basically we want these guys, drag them into the async loop region. Of course, we're going to lose our
connections for a moment.
And now in here, let me zoom in a little bit to make it clearer. Now we want to output both the video information, the image itself, but also the corners we have. And if you notice, even if it says two outputs, one of the outputs is not really an output that you can use. You can only use this one. So if you're in this situation, if you're just needing one output, you can immediately connect it down here and no problem there. But if you need more than one, then you're going to need to use what we call a tuple. And you have a 2-item or 3-item tuple. In our case, it's a 2-item tuple join. And what this will enable us to do is combine these two outputs we want into a single kind of wrapped up output.
Okay. So now we have the image and the data that we actually
inside
want.
This tuple.
So how do we get it out?
How do we get it out? This pin is telling me I have an observable of tuple. I don't know what to do with that. Well, you need a node called hold latest.
Yeah.
And this will allow you to connect your observable in. And once you have that, you can again use the tuple nodes. In this case, we need a split, which will take in what our hold latest is taking outside of the async region. And here we have again our mat and our spread of points. Yeah. So our spread of points goes here, and our image goes here and here, and we're back.
We're back, and now we didn't show how heavy that was before.
So that's kind of a shame, but we can do it right now, no worries. So you can see right now this is running around 1,500 ticks. Yeah. Right? It's not the lightest, but it's not so bad. If we were to drag this out again and reconnect everything as it should be, you will immediately notice
that's a bit of a mess now. And why don't we see the markers? Because it's not connected there.
It's not connected.
No, the renderer.
Here.
Yeah.
Yeah, exactly.
So we see the markers and we see...
But you see the timing is now around 30,000.
Yeah,
you know?
So we gained quite a bit
yes.
of performance by separating the heavy tasks in this async loop. Can you clean this up a bit? I don't want
I'm sorry.
Nobody is supposed to see it.
So you want them back in?
No,
not
just
for now. All right.
Yeah, everybody knows that you would not build such a patch normally, would you?
No.
No. We will build only very clean
very
patches.
Clean, very organized, of course, all the way through.
Yeah, but I think that concludes our session for today.
I would say so, yes.
Let's switch us back to the full screen. Let's see, closing words. I guess, I hope we've shown you how you can get started with the OpenCV pack for VL. If you have any questions, you know where to, was it that one? Yes. Where to reach us. Also use the issues on GitHub.
GitHub, of course, like. Yes.
Now I know you will all want to go around, like, share this whole thing. Just one suggestion, if you have any technical question, then don't use the YouTube comments. Come to our forum on the website or to the chat and ask the questions there. Don't ask technical questions in the YouTube channel. YouTube comments are more for, like, if you want to say, oh, Randall, you're so cute, or something, like, lol, something like that. Put that there, that's totally fine.
I'll be happy to do that. Yeah.
But, you know, keep the technical stuff separate. I think that was it. Yeah. So I hope you enjoyed.
Hey, it was a lot of fun.
We will see if we maybe do this again at some point.
Hopefully soon.
Tell your friends and parents about this, and join us next time.
Yeah, thanks for watching.
Sure. Which one? This one.